Okay, I think we are live. Today I'll be editing YakCollective's Zoom call, trying to finish up what I started last week. Last week I edited Eric's video, uh, but I think there was some problem in the music stream. That should be working now. Okay, music's on. Let's get to work.
Last night, I saw your arms around somebody. I never thought it'd be so hard, yeah. Even though I'm the one that broke us apart, yeah. Now I'm seeing her, watching you. Never felt so lonely, babe.
And if I remove this file now, this file.
I think I still need to check the voice controls of the music, but probably I'll check it later on after the stream.
Right now, okay. Now we can see the drop here, okay. The drop has been noticed, okay. So you see, we have data that streams, and that gives an opportunity if we have a program exploiting this data. Okay, so in the graph I was presenting. An opportunity if we have a program exploiting this data. Okay, so in the graph I was presenting earlier. Sorry. Showing you now it says that it's centralized. We have raw data, okay, that is shown here, okay. And so if we have a program using that, that is something that goes the evidencing, ruling, and tetrisizing, okay, which is planning. It's a step toward this, okay. But that's not very interesting to show it this way, okay, because here I'm just showing 3 curves, okay, 3 signals. Inside my tank I have much more, okay. The problem is that when we much more means more dimensions. It's very hard to visualize that. So that's why I just 3. But now I'm going to show you the same data. Wait. So can you see what's happening now?
Yeah, there is a geometric.
I need to explain. No.
Yeah, there is a geometric. Yeah, there is a geometric something in the center.
So I'm going to explain. And so what you see here is the same data, okay, that is applied to the shape you can see in the middle, okay. So, and this is where I'm not super happy with the results. I will explain why, okay? Because this shape is actually changing, okay. And you can't see very much, but let me try again now with the large file, but this should show some more significant change, okay. So what you can see here is just a and a shape in a 3D space. And this shape reveals the image. Okay? I'm there because I don't know very well the software I'm using to do that. And this is about this structure. I can't see the shape. I can show you the shape. Because the shape is actually reflecting here. Now I'll go again at this experiment of creating the large file. Okay? And so we should. Because of this shape, I compute it automatically depending on the CPU connection, the CPU and the disk usage. So, sorry, my previous test, when I was getting large files, so meaning that the disk usage was bigger, the shape was changing very significantly because I'm creating a very big file. Here we doesn't seem to work now, okay? So you know the problem is like demos, right? Oh, okay. Seven. Sorry, I'm reaching out to the server, okay? I'm going to reload the page. Is likely to change. Okay, my preview changes because now is much more space on the memory, okay? So yes, okay. You see now how it is? Okay. So this shape is calculated. You see, it's because the CPU load is holding together with it. Okay? So the shape properties, so its size, scale around the 3 axis. So you see, it's changing significantly. Okay? Depends on is coupled directly to the physical state of the rover. Okay. And you see now, if we use things like deep learning, when we can take an image and do some recognition about whether it's a cat, whether it's big, whether it's small, and so on. We have an internal state. Okay, this is the inception part. Internal state on which we can distinguish. Okay? Because if we see the shade here, it's because my memory storage is being full. Okay, so what should I do based on that? Okay. I use a 3D space to represent that. Think about it. But the thing that from the point of view of the rover, there are many more things. Okay, and the thing that there are a lot of things we can do based on that. In particular, what we can do is that once we get data over time, patterns appear. Okay, a pattern of typically of what is the normal condition of the rover. Okay? For example, what is the rover that is stopped? Okay, it stops and it's at rest. Okay, it has some shape of data. Okay? And so that shape of the data coming over time becomes that's when we can start to reason. And reasoning is a big word. Okay, in robotics it's planning. Okay? So So I wanted to show more than that today, but I didn't have time to complete. The thing that here is a demo of a of what I presented last time, but we will start on the Rover. So just I wanted to show you the how the Rover looks like, okay? Because it's very simple, okay? So it's how to say, everything is really not really it's how it's called. It's a kind of plastic, sorry, the name doesn't come back, okay? And everything is laser cut, and we assemble it completely, okay? They are very standard small servos, okay, cheap servos and so on. Okay? The whole thing cost $100, okay? In fact, the Raspberry Pi is more expensive. And inside, you can see there is a Raspberry Pi, okay? And so the thing is basically as big as a Raspberry Pi. The motors are the same as what Brett showed us last week, the one he used with his Lego. Not the Lego, the constructs, okay? So we have small motors, two motors for the wheels, motors for the arm, we have a bumper and the ultrasonic sensor at the front, okay? So all the signals to represent some shape or some tape in this I present, okay? I show them three because it's easier to understand. But you know, deep learning is very good high-dimensional data, okay? And this is where the deep learning comes into place in the framework I've been talking about so far, okay? So at the end of my presentation, would you have any question or things you would like to see again in what I've shown today?
I have some. I was not there in the this sensor conceptualizing evidence like a talk you gave last time. So I'm like curious, how is this different from reinforcement learning? What we are doing,
so it's pretty much unrelated because here I'm just presenting data. Here there is no learning at all at this point. Okay.
Was coming from, because a complicated slide with 8 different pictures seems to have learning concept building in it. So maybe if you walk us through the slide again in more detail,
yes.
Explain how it works, well, and then say where you're up to and what the next step is. I think the answer that question.
Okay, so we'll explain it again pretty briefly. Okay. So we start at the top. We have these very. So one is a photo of my oscilloscope. The others are just signals that come from different. Okay. Typically, when we plot, we have a sensor and we collect the data and we plot it over time. And this is what we get. Okay. Okay. So we take that as input. Okay. And here, what I show is conceptualizing. Okay. In conceptualizing, the goal is we have a lot of data. Okay? But what does it mean? It's editing, by the way. Okay? But the sensors are what is the entrance of the rover, okay? Of its body. It's anything where the rover can perceive comes from the sensors. So conceptualizing is about getting this data and to make, so it's basically a clustering algorithm. So machine learning is it matches in the case of unsupervised learning. Okay, so this might be where reinforcement learning could be used as well. But in my case, it's a plain plain clustering. Okay, to take data over time and to build clusters of data if there are any. If there are any.
So you're manually specifying the cluster.
If there are any.
So you're manually specifying the clusters then?
No, it's not manual. Everything is automatic here.
Okay.
Okay, is that there is, the data that comes from sensors is not really, is not random basically. Okay, so let's take, for example, a temperature sensor. Okay, the temperature sensor is collecting data over time, but the temperature doesn't change that fast usually. Okay, and so there is some stability in it. And of course, when it changes fast, there we find anomalies and so on. Okay. And also this temperature signal, okay, it's a curve that has a maximum and a minimum, that has an average, that has statistics basically. And so because of the statistics, we can relatively easily build a cluster of the data that comes from there. Okay? Do I make sense?
Yeah, I'm totally getting.
So it's just that clustering here, I think it's because it's first topic, it's a topic, and it's using data that you it's on the statistics of the raw data. Okay? But it's possible to take reinforcement learning and look into that. It's also possible to take a much easier approach to the mean of the mean, the max, and the mean. I mean about the mean and max, for example, and to take that for each, and we can discuss that way too. Okay? The target of conceptualizing basically is to take time data basically and to summarize it. Okay? And by summarizing it, we get some stable or slowly changing data. Okay, there is some stability. Okay, it's that the point is atomic, and it's based on the statistics of the. But it's better to reinforcement learning. I didn't look into that at all. Okay? It's also possible to take a much easier approach to directly the mean of the mean, the max, and the mean. I mean, I don't need the minimum, the mean, and the max, for example, and to take that for each signal, and we can build the clusters that way too. Okay? Basically, state real-time data basically, and to summarize it. Okay? And by summarizing it, we get some stable data. Okay? Stable or slowly changing data. So once we have these stable data point, the set of data points, okay, the rover doesn't have any idea what these are. Right? I mean, we have the points here. I put a label, go to A, and this is a rock, and this is going forward. Okay, but these are this is not a labeling. Okay? The thing that they are communicate to each other. So the relation imaging. Okay, so this is what a baby does typically. Okay, is that well, this is how I imagine a baby is doing. Okay, is that when a baby starts to explore its world, okay, it's basically collecting data image. Okay, the image that is yes. Okay? But as it's collecting more and more and more, the baby is actually related to each other. And so over time, some labels emerge. Okay, and so what I'm trying to do is to build these clusters and step by step to be able to build the labels. Okay? So there is a lot of alignment with maybe Rover will come up with this. Okay, so alignment for sure. Okay? After I moved here to the step of evidencing. Okay? So evidencing, so strange way because I don't have spent much time on the terminology yet. But evidencing is production reasoning. Okay? So it's about finding evidences, okay? About finding facts in the data we have in the world. Okay? And so here evidencing is about creating tentative goals. So the goal is to go towards something like planning that we have in standard robotics. Okay? Standard. I don't want to sound negative. Where we have in planning we have a set of symbols. Okay? So this is a rock. This is going forward, this is going backward, and so on. Okay? But it's not grounded in the body of the robot, okay. The rover. Okay, they are grounded in they are just high level concepts that after we manually plug into the body of the rover. Okay, here I'm
or maybe grounded in the affordances the robot could have, because
the body of the rover. Okay,
or maybe grounded in the affordances the robot could have, because the sensors are basically what sensing. It's like kind of an indication of what the affordances robot has.
Yes, that's it. Yeah. Okay. So there is this dimension of the work where, for me, there is a whole body of work that is very important, where the rover can discover its own body, basically. Okay, what it can do with his body, and if we can achieve this feature, it's pretty interesting because it makes the rover much more robust. A rover that has discovered his body knows it has and one caterpillar gets damaged. The rover will be aware of his body, is able to be aware of his body, will know that. If there is a learning component as a support, it should be able to can, despite this. Okay, so I continue on the evidencing. So evidencing is about making a tentative rules. Okay, about what I can do with me as a rover. Okay, and how I can conceptualize my situation. Okay, so where I am, what is around on the step like that. Okay, what is the direction, and so on. So it creates long list of rules, okay, and it keeps track of frequency. Okay? And so something that rarely, okay, is regarded as an exception or not relevant. Okay? But then the rules that stick around, that come over and over and over, is that if I turn the on, it will stay forward. Okay, so the rover learns by itself, turn motor on, location goes forward, basically, something like that. And so tentative roles with high frequency become rules, and this is where we enter the next, which is ruling. The rover accumulates of the other long life. Okay.
Basically, what I'm trying to do is try to have cuts wherever the speaker changes. Let's see if there is a way to automatically do that in DaVinci. Seems like there is. Seems like it's not possible at the moment, but I will try to find that later on. Let's continue with the editing.
More data may change them over time still, okay? This is very important. This is why we have this continuous loop, okay? So ruling is about stability, but not, it's not indefinite. It's not indefinite, okay? If at some point my PyTank loses its arm, okay, all the rules about the arm should be changed. Probably lost, okay, but should be changed. And so once we have a set of stable rules, okay, this is where we can start reason, okay, to reason, okay. So this is the T3 sizing, okay. T3 sizing is about planning, okay. I just wanted a different name, but it's basically planning, okay. Planning is about okay. So the rover learns by itself, turn motor on, location goes forward, basically, okay, something like that. Okay. And so tentative rules with high frequency, tentative rules with high frequency become rules, and this is where we enter the next step, which is ruling. Okay. Where we have the rover accumulates a list of long-lasting rules. Okay. They're not okay. The more the T3 sizing. Okay. T3 sizing is about planning. Okay. I just want a different name, but it's basically planning. Okay. But planning is about we have a set of capabilities, actions we can take on the environment. Like, oh, I'd like to sense this. To activate my motor, I'd like to activate the camera and this stuff like that. Okay. If you have some experience with ROS, there are a lot of things to do for that inside of it. And so basically here is that we have rules that are available. It's our API. Okay. This is what the ROS provides us, and how we want to use ROS. How we want to use the rules to do something in the environment. So this is the last step. Okay. To send a command to the environment. Okay. And so there is an analogy, a clear analogy with what we do in robotics, but here everything is data driven from the beginning to the end. So sorry. I'm very not confident that I'm doing a good job at explaining this, but Anuraj.
Yeah, now I understand it much better.
This, but Anuraj.
Yeah.
A different name, but it's basically planning. Okay. Planning is about we have a set of capabilities.
Now I understand it much better. Thanks.
Good job at explaining this, but Anuraj.
Yeah, now I understand it much better. Thanks.
Thank you, thank you. But now back to reinforcement learning. So it could fit at different stages, okay, along this. Let's call it a data pipeline. Okay. Perhaps you are seeing it in the current stage.
Yes, and then there is a loop, so it seems like we are. Yes, and then there is a loop, so it seems like we are trying to get some sort of RL.
And yes, and so I think in practice it's possible. So reinforcement learning for is basically reinforcement learning is a policy. Okay, and so it's interesting because the terminology means something here because the policy is you can see it as a big table. Okay, and a set of rules as well. Okay.
Okay, I think most of the settings are working now. The music volume. So that was today's video editing session. See you until next time.